Hi guys, welcome to PyHacks. Today we're going to be looking at looping and iteration in Python. We've done this quite a lot in the dictionaries, the lists, and the sets and the dictionary examples. So refer to those. Today I'm just going to be taking you through a few more examples as a side of what you can do with looping. So let's launch into our Spider editor and get going. So the first concept we're going to examine is while loops. So while loops, a little bit around the intuition on while loops. So a while loop says what I'm going to do is while a equals true, so this will be my condition, set it to true, so it will keep looping through those values while they're true. So it starts with the assumption that everything's true, so it'll loop while they're true, and then when it becomes false, it terminates. So that's how a while loop functions. So back to the examples then, let's get coding some of these up. I'm going to set my iterator object, so I'm going to call it I, equal to 1. I'm going to have a terminator as well, so where it terminates at. So say 100 iterations. For some reason, Tab autocomplete's playing with me today. So while I, as we saw in that diagram, so this is the B condition that you saw. Let me just bring that back up again. That's this A condition here. So while A is true, so while it's true. So while I is less than or equal to my terminator, so while 1 is less than or equal to 100, print, I'm going to use replacement fields again, the value of the iterator I is, I'm going to use a replacement field here, I'm going to pass in format, I'm going to format I, okay? So what that'll do is it'll start to iterate. But if we don't actually say that we want it to keep going, what it's going to do is create more or less an endless loop because, you know, it'll have issues. So what we're going to do is increment that each time. So we're going to increment the value of I each time. So to do this in Python, we need this notation. So you use I plus and equal 1. So it essentially says for each time this iterates, it's going to move the iterator up by 1. So it's going to go loop 1, then it becomes 2, then 3. So this I value becomes 1, 2, 3, 4, 5, all the way up until it gets to 100. So, and we're also going to add in here an else statement. So we just want to print something when it terminates. The value of I is no longer less than or equal to 100, finishing loop. Yep, okay, you'll see that print at the end. So let's highlight these, make sure we've got everything right. There we go. F9. So you can see what's happened there. We've got this I value that's been iterated. Remember that Python starts at 0 indexing. So really, actually, that would have gone to 99. So it's gone while I1 is less than or equal to terminator, which is 100, do this loop. And then I've got a count of each of the iterations. So I1, like I said, 1, 2, 3, 4, keeps adding to it until it gets to 100. And this is the same as the length of a data frame, the length of a dictionary. It does the same thing. It adds this termination object. So the length of a data frame would be the termination object. Okay, you can see that the else statement's now printed saying that the loop's finished. Okay, so a couple of other things to know about loops. So we're going to add these in. We've got something called the break statement. So the break statement, when it reaches a certain goal, will break out of the loop. So we're going to set this up again, I equals 1. I'm going to use the terminator value that we used earlier. So while I is less than my terminator, print I, I'm not going to put the replacement fields this time, I'm just going to print what the value is. And then we're going to add an if statement in. remember, indentation is really important. So if say if it's equal to halfway, because we know it's up to 100, isn't it? We're going to use the break statement. And then what we're going to do is inside the iterator, make sure that this is not pushed to there, otherwise it will be in this condition and not the outside condition. Again, indentation is really important because we want this inside the loop like we've had before. If we add the if statement, it's adding it to the right, so it's another statement within it. So that wouldn't work right. If I is less than or equal to 1, not less than, what are you talking about? So I is equal to 1, while I is less than the terminator, print out I. If I is equal to 50, so if it gets halfway, break out the loop and then keep going. So just you'll see what happens, and then append to each iteration, sorry. So you'll see an iteration that gets up to 50. Because we've put this if condition here and we've specified that we want to break out the loop, at that point it's not going to continue with the loop, it's going to break at that point. So it's actually found the value that we're looking for. So this is normally used if you're searching for strings in lists, or you're searching for certain values and you want to find one specific value, you want to find the median, whatever. That's when you'd use a break statement. There's another variation of this called the continue statement. So as that breaks out the loop, what do you think the continue is going to do? It's going to continue on with the loop. So we're going to structure another loop. We're going to keep doing this. And I suggest that you code along with me. It helps with learning Python and any programming language. So we're going to say, while I is less than our terminator, spelled it wrong. While I is less than, then we're going to go I plus equals 1. So make sure that it iterates every time it goes through I. And then I'm going to say if I modulo, so the remainder of 2. So I'm essentially looking for odd numbers here. We're going to do a little odd and even number finder between those values. Print found the odd value. And the module operator will look for the remainder of a division. Dot format I. So it's going to use replacement strings. It's going to say if it's the remainder of a division, so I remainder of 1 will be an odd. 2 won't be able to be, there won't be any remainder left, so that'll be the even number. If we go to 3, there'll be a remainder of 1, and so on. It's going to find the odds and evens between the values. Then I'm going to say here, this is important, instead of pressing break, I'm going to say continue. And then outside of that, as you can see, the Spider editor's already handled the indentation for me. The print statement needs to be outside of here. So this is the even number. And if you see what it'll do in a minute, I'll show you in a second. Dot format I. So let's run this whole thing. But let's set the terminator up to something stupid like 1,000. It's going to look at every odd and even number between 1 to 1,000. So, has that worked? Yes, it has. So the odd value here is, there's too much to print in the console, so let's get back to 100. Okay. You can see that all my values are there. So 2 is the even number, because the modulator will either return the remainder of a 1 or a 0, dependent on the division that you're undertaking. So it's essentially I, the current I value divided by 2. The modulo of that remainder is going to be 1 or a 0. And it's going to allow you to indicate where the odd and even values are. So 2, it's found that that's the even number. 3 is the odd, and so on. So you get that all the way up there. You can even do massive numbers, but this will take a while, and I'll probably end up terminating the loop in a second after it. So you can just keep going with the iterations. You can see my CPU starting to ramp up and my GPU as well. Keep going as long as you want. want to terminate out that, you can also press Control and C to terminate in editors like Visual Studio Code, etc. So that's how you'd use the continue statement. It's actually achieved an operation, it's found the odd value, but actually it's going to keep continuing in the loop. And that's really good when you're iterating through and performing searches, so creating custom searches. So I used to use this for iterating through a whole pandas data frame and finding certain values and marking them in the specific fields. So marking it, but also creating a new column with those markings or tags. You can even do things like feature encoding. So, if it matches this value, then return a 1 or otherwise a 0. That's how domain encoding essentially works. Just a loop with a continue statement. Anyway, that's probably a bit more advanced than we need to be getting into at this stage, but that's how you use the break and continue. So we're going to go into for loops now. So in Python, most of the time you're going to be dealing with objects. So you're going to go for each item, so for every iteration, so for every item in that object, so whether it be a list, dictionary, whatever, do something. And that's essentially it. So we can go through characters, through chars, in a string. So for char, so for character, I'm going to pass in the string. You could set it as a variable, I love Python. It's awesome. It's awesome. Then I'm going to go put my little end colon there for char in I love Python. Sorry, I've got hay fever today. Print the letter is. So we're going to loop through each letter. I'm going to use replacement strings again. Dot format character, so our iteration object. As you can see, with the while statements, you've got to actually set up the initiate the while statement. You've got to terminate it in this setting. So if you're looping through numbers, for loops are a lot better normally. Or you're looping through objects as well, are normally better. While statements come into their own. Things like if you're waiting for user input and you want to loop through a whole set of inputs, you can set it to while true until the user's inputted something into the console, then that becomes false and it terminates. Or if you're using things like computer vision and OpenCV, you tend to, if you're capturing video streams from webcams and doing object detection or facial recognition, you'd use a while loop to essentially keep the webcam running until someone presses the quit button, etc. That's where while loops become really useful. Again, normally for looping through objects, I'd probably default to for loops. Okay, so let's try again what we've done before, looping through a series of words or items in a list. I'm going to use the break statement here. So we're going to try and find one of these items in this list, like I talked to you about earlier. So for my programming languages that I like, Python, R, SQL. I also like, let's add one to that, C#. I like C# as well. For programming languages, for I in programming languages, print the I. But if the I is equal to R, then just break the loop. So we know what break does, it's just going to terminate it. So it's going to print every item up to R and then ignore the previous two. So we could also use a continue statement, and I'm going to show you how we'd utilize that. So as I said, a way that you could use continue statements, let's use the programming langs. We'll use the programming langs list that we've created. But we're also going to create a found value list. Let's call it a found value list. We're going to initialize an empty list. Again, refer to the list tutorial if you're unsure what all this means. I'm going to say for I in our programming langs. So for every item in that list, I'm going to print the I initially, print the item, and then we're going to say if I equals, I'm going to pass multiple things here, but we're just going to do one for the sake of example, equals R, Then we're going to use the append method of that list that we've just created, found value list dot append, and we're going to append each of those ith values that we're iterating through. Okay, and I'm going to say print. I know you like Gary, but I am going to keep on being loopy. And then we're going to use continue here. So as we've seen before, continue will still continue the loop. So if I run this line now, and it's going to work because we've got programming languages instantiated here. It's actually in memory. Okay, so what has this done then? So it's gone through each of those list items, bum, 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 each of those items of 4, and it's stored our terminator object up to that silly amount that we put. And what it said is, actually, the loop's gone from Python R, and it's found R in the loop. It's this if condition's correct. I know you like R, Gary, so it's printed this value because it's found that value, but it's continued going through those list of items. But what else it's done is it's when it's found that value, it's also appended that value to a list. Yeah. So you could have then actually, if you had an else statement there, you could just keep appending all the values with some kind of trigger. You could add another if statement saying, this is the value that you need, this is not, or this item's 1 as a flag and this item's 0, or this item's yes, this item's no, if you're doing like data flagging. So that's the way that you could work with that. So let's just talk about a few other things. So looping through a range object. So a range object is just a range of numbers. So similar to how we put terminator at the end of the while loops, you could do something like this. For I in range, and the range up to 10 numbers. So it'll start 1, 2, 3. We're going to print I. So it's going to start at the 0th index. A way that if you were then going to include this in a list, you wanted to make it start at 1, you could just increment it by 1. So it starts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just how you do it from a range object, just specifying the end limit that you're looking at. You can even say something like the length of a list. I don't know. If you're looping through lists, etc. So if I wanted to do that with start and end parameters, and someone's house alarm's going off by the sounds of it, apologise if you can hear that. In range 1 to 10, print I. So yeah, starts at 1 to 10, but it never includes 10, it's going to go up to 9. So let's say 11 to get to 10, yeah? Okay, so that's a start and end parameter. Another way to do that is if you wanted to do a range between, but you want to go up by a certain value, so go up in 2s, etc. Like odd numbers, odd and even numbers as we did earlier. You go full I in range. You can see how much these objects, if you know the size of the item that you're looping for, it can reduce the amount of code that you need to write. But these would be if you know the index and how large the index was. Otherwise, you could just loop directly through the list. So if I want to go from let's say 1,000 actually, for I in range starting at 0 to 1,000 and go up by 10, I'm going to print I. So it's gone up in tens a lot, as you can see. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so that's how you loop through ranges. I'm not going to go into much more than that for now. But range is just a range of values of items. If you're dealing with time series data, it can just be a range of index items alongside a particular date. Okay, let's do an example of nested loops then now. This will finish this tutorial. So I'm going to do a nested loop, and we're going to work with, let's recreate a times table in GCSE maths or high school maths for x. So for x in, I'm going to use the range objects again, because we go 1 to 11, so from 1 to 10. For y in range, and this is how you nest your loops. And the result of the nest always goes in between here. I'll show you in a minute. 1 to 11. And we're going to say our result is x, because we're doing times tables, x times y. And we're going to print out the result. Print the, I'm going to do replacement. I'm going to do the values, the multiplied by value is, and then we do a result as well. I'm going to pass in multiple, is equal to, put that in there, something like that. Dot format. So the first format item I'm going to pass for my x is my x, my y, and my result, because you can put multiple items into this. And to do the formatting, actually, if you wanted to format by to float, you'd do it like that, like a floating point. But we're not going to get floating points here, so that doesn't matter. I'll talk to you about string formatting later on. So if I F9 this, non-type job is no attribute format. Yes, it does. Okay, I see. I put parentheses in place. There we go. So I just need to put it outside of the print statement here, and there we go. Right, let me just add some spacing. Okay, let's run that again. So actually, I don't need that was silly. So, times tables then. 1 multiplied by 1 is equal to 1. 1 multiplied by 2 is equal to 2. 2 multiplied by 1 is 2. 2 multiplied by 2 is 2. 2 multiplied by 3 is 6. And so on. So that's working. Does it go all the way up to 10? That's another check. Yep. So we know that actually we've got a 10 times table rounded off there. Because for each x, so every time it loops through this range of 1 to 10, it's going to loop through that, and then it's going to loop through the first item in this one. So 1 pass, and it's going to go back to the top, and then it's going to start at number 2, and it's going to loop through every item in that range. So for the first 1 in that range, it's going to do the y 10 times. For the second x, it's going to do the y 10 times. For the third x, it's going to do the y 10 times, the amount that was specified in the range. And that's why I know that it's going to go start at x, do this 10 times, go back to the start, 2, do this 10 times, go back to 3, do this 10 times, go back to 4, do this 10 times. And then the result, each time the result gets calculated, we're going to have this x times 4, and then it's going to print out every time it does that. So it prints that into the screen. We could actually append this as well. So let's create a times table list just to complete our exercise. Add those values in. Oops. Times table list. And then here we're going to go times table list dot append. I'm going to append the result. Okay. So there we go. So with the times table list, you should have a list of 100. So we've got if I want to just check out each one of those values now in our times table list, I could do another loop for list item li in whatever you can call that, whatever you want, in times table list print li. Okay, and then you'll see that all those values are in there as we've just done. So we've got those values, and then we could do silly things like create sums of those and whatever else. No, sum of li, isn't it? Create the sum of the why you'd want to do that, I'm not too sure. You'd want that outside of there though, wouldn't you? Nope. You could just go sum times table list. That's what I need to do. I'm doing a global sum times table list. Huh? Yes. Times. Okay. So it's going to sum up all the values in that list. So you do then global operations on that list, but summing up all those values is not going to be right. You'd want a sum of each one of these every time it goes through. Summing up's just irrelevant anyway. You won't want to be doing that. But then it gives you the times table list that you can then work with. You can even add a value there as well, saying, you know, the result of the item is. So you could create a dictionary then. So index 1 is this times by this, etc. However you want to add it. Anyway, that takes us through loops. So what we've covered is while loops. We've done break and continue, why you'd want to use those. We've used if conditions with inside loops. We've created a times table example. We've gone through some kind of search index that then returns a result and passes it to a list. We've looked at looping through ranges. So I hope you found that interesting and useful. I've really enjoyed teaching you. Please subscribe, hit the subscribe button. Can't get enough subscribers. The associated GitHub is also contained with this tutorial. So please store the repository, please fork it, please download it, pull it, whatever you want to do with it. All your help is really appreciated. So yeah, guys, catch you on the other side. Bye.